Hel- Hello, everyone, and a warm welcome to our session. Let's wait another couple of minutes, but in the meanwhile, feel free to write in the chat your name and then the country that you're joining us from. Thank you. Hello, everyone, and again, a warm welcome to our session in the Workflow Forums for Better's Masterclass series. The Workflow Forum stands as a collective effort dedicated to youth empowerment and the transformation of our global agri-food systems. Through this series, our aim is clear: to cultivate the skills, passion, and commitment of the next generation, fostering meaningful and sustainable change. Today, we are thrilled to deepen our knowledge of soils. This topic is extremely important, and today we will focus on soil salinity and biodiversity. This is our second session with our colleagues in the Global Soils Partnership team. And if you are interested in seeing the first session, please visit our Youth Skills Hub webpage, which you will find through the link that shortly will be shared in the chat. The Youth Skills Hub is a platform that equips youth with knowledge, skills, and confidence for the workforce and improving agri-food system. It moves around three pillars. The first one is a series of skills-oriented masterclass to educate participants on agri-food systems, as the one that we are here on today. The second pillar is a list of career opportunities made up of internships, volunteer position, and jobs to help young professionals to apply their skills. And then the third pillar is the online library that offers technical resources and interactive e-learning for professional development. These sessions and these masterclasses sit at the heart of our effort to highlight FAOs for betters, better production, better nutrition, better environment, and better life, by equipping you, the change makers of tomorrow, with vital knowledge and practical solutions. In today's masterclass, our focus narrows to better production, understanding the science and strategies behind managing salt-affected soil and their implications for biodiversity. Together, we will explore how soil health forms the bedrock of resilient agri-food systems, ensuring productivity and sustainability for current and future generations. To give you a sense of what you could expect from today's masterclass, here is a brief overview of our agenda. We will begin by examining the fundamental characteristics and global impact of salt-affected soils, followed by an in-depth discussion led by our expert from FAO's Global Soil Partnership. We will explore case study, practical strategies for soil and water management, and biodiversity preservation. Our session will also feature an interactive Q&A segment to foster a rich exchange of ideas and insights. We will then conclude the session with some closing remarks. This journey is guided by FAO's Global Soils Partnership, and we are honored to welcome our expert, Dr. Maria Koniushkova and Dr. Jacob Purnell. Dr. Koniushkova brings extensive expertise in the study of salt-affected soils across diverse regions, while Dr. Perner's work on soil biodiversity offers critical insight into how life thrives and adapts under challenging conditions. Today, our objectives are clear. Our masterclass will consist of the distribution and management of salt-affected soil by food producer, and you will gain and learn essential skills and gain knowledge about soil salinity, its impact on biodiversity, and how to manage salt-affected soils. This will be a collaborative effort where when we call you for active engagement, thoughtful reflections, and shared learning experiences. So now at this stage, without further ado, it is my pleasure to hand the floor over to our esteemed experts from the FAO's Global Soil Partnership. So join me in welcoming Maria Konushkova and Jacob Parnell. Colleagues, the floor is yours.
Hello, dear participants. My name is Dr. Maria Konyushkova, and I specialize with salt-affected soils in the Global Soil Partnership. I studied these soils in the dry regions of the world, including Taklamakan Desert in China, Aral Sea area in Central Asia, and the Caspian Sea coast in Russia and Iran.
My name is Dr. Jacob Parnell. I also work with the Global Soil Partnership, and I'm a soil biodiversity specialist. I grew up on a small farm in the arid western United States near the Great Salt Lake, and I've always loved playing in the dirt.
Thank you so much for this presentation. I think we can start.
So now we will watch a video about salt-affected soils, what they are, how they appear, and how you should treat the soils if you have them on your field. Isabella, please.
Salt-affected soils include both saline and sodic soils. Saline soils contain an excessive amount of soluble salts. The presence of soluble salt makes it difficult for plants to absorb water from the soil. Sodic soils carry high amounts of absorbed sodium ions that damage soil structure. Soils become hard and compact when dry and sticky when wet. Both saline and sodic conditions considerably reduce the agricultural productivity. Over 833 million hectares are salt-affected soils. The map currently covers 73% of the global land area. What are the drivers of salt-affected soils? There are natural and human-induced saline and sodic soils. In arid, semi-arid, and coastal environments, saline and sodic soils are naturally present. These soils are not degraded, but typical of these landscapes, where halophytic vegetation is present. The Uyuni Salt Flat in Bolivia is an example of this type of landscape and soil. All the saline soils surrounding the lake are used to produce crops, particularly the quinoa reel, which is a very nutritious crop. These soils also produce natural vegetation eaten by camelids. Human-induced salinization and sodification. The main drivers are unsustainable agricultural practices, irrigation with poor quality water, removal of deep-rooted vegetation resulting on raised water table, water pumping at the coastal plains, overuse of fertilizers. Because of climate change, soils at coastal areas are facing seawater intrusion, causing salinity and sodicity. What can we do? Conserve natural ecosystems prone to salinity and sodicity. Manage soils and water sustainably. Apply appropriate irrigation practices and adapted crops. Manage salt-affected soils in harmony with nature. Let's work together to halt soil salinization and boost soil productivity.
Thank you, Isabella, and dear participants. I think that this video was very informative in the sense of understanding the genesis, the main factors of appearing these
Bastano poche
soils.
bustine di cibo terapeutico e un bambino malnutrito può guarire.
Of appearing the soils, and now we will go in more detail of understanding salt-affected soils. Isabella, please share the slides.
Se non si interviene subito. La soluzione c'è: il cibo terapeutico pronto all'uso.
Thank you. So sorry for these technical issues that we had, but we will compensate with the interesting talks about salt-affected soils and biodiversity. So here on the slide, I would like to show you the distribution of salt-affected soils and discuss it in more detail, saying that the salt-affected soils are found both in coastal areas, so when you have the oceans and the seas, but also in inland. So they can be there due to the existence of the ancient seas. So when we had the deposit, when we have the parent materials for soils, which is saline. And also the salts can accumulate in their closed basins, where the outflow of water streams is restricted. So according to the latest estimates performed by FAO in the last years, now we have the updated numbers about the total area of salt-affected soils, which says that we have almost 1.4 billion hectares of such soils worldwide, which makes almost 11% of the total land area, which is affected by salinity and sodicity. And if we look deeper into the areas of the cropland, there we can see that 10% of the total cropland is affected by salinity. So what is the main effect of salinity on the crops? So the main interesting fact is that salinity and salts per se are not very toxic to plants. But the most important factor that leads to the deterioration and degradation of crop growth is the decreased availability of water. So what we can see And what we observe when we have salinity in our soils is that the crops that are not adapted to salinity, they show signs of drying, even if the soil is moist. So you can see the field which has enough water, but due to salinity, the crops will show the signs of drying. It's quite an interesting fact, which is caused by so-called osmosis. So we have the reduced osmosis, which is restricted in salt-affected soils. When the solid concentration is too high, the process of osmosis is interrupted, and the plant cells are unable to take up water and the nutrients from the surroundings. So this is what we observe under saline conditions. Another conditions, which is called sodicity, and we can observe in sodic soils, which is a bit different from salinity and managed differently from saline soils. Here we observe reduced water infiltration and increased water logging. And this is caused by the effect of the dispersion of soil particles. So when we have many particles which have adsorbed sodium, we have the soil dispersed. So this is what we can see here. And on this illustration, you can see how the soils differ in the sense of their structure and their compaction. So dispersed soil, they're very compacted, the pores are very small, and the water cannot go through the particles and through the aggregates. And in the case of dissolved sodium, which we have in saline soils, which can be easily leached if we have enough water resources. In case of adsorbed sodium, which we have in sodic soil, it's very difficult to remove the sodium from the soil. And in this case, we have special measures which are mainly related to the calcium containing amendments. And this process is very, let's say, long-lasting, so we need more time for soil to reclaim. Then, if we look at the salinity levels to understand what is high, what is low, so we can compare, and actually we can evaluate the salinity level by our tongue. So the human sensitivity to the threshold of salinity sensitivity is about it can range from different people, from different they have different sensitivity, but in general it is concordant. It's in the level of the moderate salinity. So when you can feel the salinity in your soil by the tongue, it means that we already have moderate salinity. And in this figure, you can see that under no salinity, slight salinity, and moderate salinity, we can grow different crops, actually. So when we have the higher levels of salinity, we can grow only salt-tolerant crops. So those salt-tolerant crops are the crops which are the normal crops, but which were selected to be adapted to salinity. And then we can, when we grow the level of salinity in soils, when we have the raised more higher salinity levels, then we can grow only halophytes. So in extremely saline soils, there are only the plants that can grow, and they are called halophytes. And these plants, what is specific about these plants, that they have increased production under higher salinity levels. So which means that these crops love salinity. But then when we continue increasing the salinity levels in soils, then even halophytes cannot grow, and only specific crops, which are called euhalophytes, can grow. So then if we go to the measurement of salinity to understand how we can measure the salinity, so there are simple devices which are called conductimeters. And if you want to measure your salinity, you take teaspoons of soil, which makes about 50 grams of soil, and you mix it with 50 millimeters of pure water and mix it with a stick. So we make 1-to-1. It is called so-called 1-to-1 ratio, soil to water ratio. And then you should wait until the suspension precipitates, and then you measure it with conductimeter. And here you can see the thresholds for different salinity levels. So here the thresholds are given to the for the soil paste extract, but for your solution, 1-to-1 solution, the threshold should be 1 decisiemens per meter. When you have the salinity level less than 1 decisiemens per meter in 1-to-1 water to soil solution, then you can say that your soil is not saline. When it is above the threshold, then the crops that are very sensitive, which are sensitive to salinity, they feel worse in such soil. If the value increases, then you need the crops which are tolerant to salinity. And if your value is more than 8 decisiemens per meter in 1-to-1 water solution, then you can grow only halophytes in such soils. Jacob will tell you more about these amazing plants which can grow on salt-affected soils and how microbes can help your plants to grow in saline soils. Over to you, Jacob.
Thank you, Maria. I appreciate that. Can we go ahead and play that first video? Thank you very much. So one of the things that I hope that you got from this video is just an awareness of how full of life soils are. Soils are basically the birthplace of terrestrial life as we know it. And so one of the things that we need to remember is that all soils are going to have some measure of biodiversity. Maria mentioned early on that there are some soils that are naturally occurring that have very, very high salt concentrations. And so there are organisms, there's biodiversity that has adapted to that very, very high salt conditions, and that are naturally occurring. And those are valuable ecosystems. They do provide some benefits and some ecosystem services. However, the soils where we're talking about for most of this production are soils that we are trying to either start to be able to produce on soils that have higher salt, where, as Maria mentioned, normally these plants will not survive, or else we're talking about taking soils that through unsustainable agricultural practices have become higher in salt. And so those are kind of those issue areas where better production really falls into play. So one of the things to notice is that as we change the salinity of soils, we start to change the microbial biodiversity, and we start to see that there are insects that cannot survive in high salt concentrations. And so we start to lose some of the biodiversity as we start to get higher in salinity. So on one hand, we see that the increase in salinity has a negative impact on biodiversity. However, the salinization also impacts the way that the plants and the microbes and the soil biodiversity interacts. And they can work together so that both the plants and the soil organisms can survive in a hostile environment. So you see here, one of the things that researchers have been able to do recently is that they're able to take the microorganisms that thrive and survive in the roots of halophytes. So you'll remember that Maria talked about halophytes as plants that are naturally evolved and adapted to survive in high salt concentration. So these are plants that don't really produce anything for us, but that live in high salt concentrations. And these plants have microorganisms that live and thrive in their root systems that actually help them survive those high salt concentrations. So one of the things that researchers have been able to do is they've been able to isolate those organisms, those microorganisms, and then they're able to apply those to regular plants that are trying to survive in salty soils. And those microorganisms then are able to also help these plants that actually produce crops and produce some kind of nutritional value to us as humans and to animals. And thereby it makes it so that these soils that normally wouldn't be able to host these plants are a little bit better production. So this is one way that researchers are trying to study these high salt environments to give us clues on kind of life and how life adapts and how these plants survive so that we can make these crops survive in these higher salt concentrations. And this this helps us to be able to start to use some of these either naturally occurring soils as places where we can start to grow our crops, or else, you know, we can start to help the plants that are under these soils that have been degraded, that we can actually start to provide some benefit out of these and hopefully start to produce from these soils again. So we have developed a quiz where you will be able to answer some questions about soil salinity and biodiversity. And for the three winners, so the three that answer the questions correctly, there will be and are the fastest in answering these questions, there will be a certificate that you can get as far as being a ambassador for soils for better production from salt affected soils. So we are now going to, you should have the pin to the Kahoot quiz that's going to be in the chat, and we will now open up this quiz. Maria, do you want to run the quiz for us?
Yes, so I'm sharing my screen. Dear participants, please enter to kahoot.it. So I share the website, the link to the website in the chat, and please enter the pin of this quiz. So I also enter the pin into the chat. 7566668. So we can see our participants joining. So now we see 6 participants. Let's wait until others manage to join. So here in this funny quiz, you will be able to answer questions which are based on the information that we shared during this masterclass. So we will wait for 1 more minute so that people join. Please enter your name. After you enter your PIN, you are invited to give a name. So we have 13 participants who joined. As soon as people are continuing to join, let's wait a while. So we can see that everyone who wanted to join already here. Oh, more people are coming. Okay. Let's give others to join. So 10 seconds. And then we start the Kahoot. 10, 9, 8, 7, 6, 5, 4, 2, 1. And I run. On your screens, you will have a question. The first question is, what are halophytes? The options to choose. They are salts that are loved by plants. They are plants that love salts, and they are plants that suffer from salinity. So choose red, blue, or yellow. You have 40 seconds left. Twenty seconds left. 10 seconds left. 5, 4, 3, 2, 1. So we can see our results. So here we have 13 answers which are correct. And the correct answer is definitely that are the plants that love salts. So let's see who was correct. So the one who was the fastest and gave correct answers was Sergius. So let's continue with our next question. Question number 2. The main drivers of human-induced, or another name is secondary, soil salinization are: first, irrigation with poor quality water, poor irrigation and drainage methods, removal of deep-rooted vegetation and the raised water table as a consequence, water pumping at the coastal plains, or all of them. Choose the right color. 30 seconds left. Fifteen seconds left. 5, 4, 3, 2, 1. So the correct answer is all of them, because all of them can cause the secondary soil salinization. And let's see who is the winner of this after 2 sessions. So after 2 questions, the winner is the Chels. So congratulations to Chels, but let's see who will be the final winner. Our next question. Question number 3. How can soil biodiversity improve production in saline soils? Soil organisms eat the soils. Soil organisms help plants to adapt to soils. And soil organisms create rain to wash away soils. "30 seconds left. Five, four, three, two, 1. So almost all participants gave a correct answer, which is soil organisms help plants adapt to soils. And let's see the winners. So the 3rd place goes to Angrima. 2nd is Himayat Khan. And the 1st winner, the winner is... So congratulations to Chelsea. Dear participants, so the 3 winners, please share your full name and your email in the chat so that we can send the certificates of the ambassadors for salt-affected soils to you. Thank you to all, and we continue. Over to you, Isabella.
Thanks so much, Maria. I think it's time for some Q&A. I see some questions right now that is in the chat. So the first question we have is from Elias, and they say, how do you measure the health and nutritional quality of a crop produced in a soil salinity affected farms? Over to you.
Actually, it's quite an interesting question, because so the nutritional quality of the crops which are produced on salt-affected soils sometimes even higher than of those which are cropped on the normal soils, because the salt-affected soils can contain more nutrients for plants to absorb. But still, the researchers so different research give different results. So sometimes it's better, sometimes not. So there is no, let's say, consensus on this. But I would say that from my personal perception, so quite many quite much of food which I tried, which is grown on salt-affected soils, is very tasty. Then regarding the health of crop, so we can see the signs of, let's say, bad condition of crops, that it will become like dried. So the main sign of it is the drying. So if you have these signs, you can see that your soil is moist. You can measure salinity to see if it is the factor of the crop damage. So maybe Jacob can add something to this.
Yeah, that's a great question. Oftentimes, so Maria had mentioned that there are some crops like quinoa that will tolerate higher salt concentrations, but oftentimes we want to grow the same kinds of crops on salt-affected soils. So, for example, if we were growing corn or wheat, we still want to be able to grow that corn or wheat on that same soil. And so we try to minimize the salt damage. And so we often don't see an impact on the quality of the crop. What we do see is we see that there is less production. So we don't see as high of a yield. It's almost as though, as Maria mentioned earlier, it's almost as though the plants can't get enough water. And so it looks like even though there's plenty of water there, salty water, but the plants are drying up because they can't really access that water because of all the salt that is basically sucking the water away from the plants. And so it really looks like the plants are drying up and they're kind of burning out. And so we don't see as high of a yield, as high production in those areas. And that's where hopefully we can get some of these microorganisms, these endophytes and epiphytes that will work with the plants to be able to help the plants to get more water and to be able to produce better in these environments. And so it's not necessarily the nutritional quality of the crop. It's more that we get more of the crop itself.
Thanks so much, Maria and John. I see some hands up in the chat. First, we can start off with Tanvir Ahmad. If you want to unmute yourself and ask your question, please go ahead. I think that you're muted right now. Please unmute yourself and ask your question. We can't hear anything. Perhaps we can move to the next hands. I see. Oh, okay. Go ahead. Tanvir.
Assalamu alaikum. Hi, good evening.
We can hear you. Yes, continue.
Yes, thank you very much for such a good presentations. I really appreciate the efforts of Dr. Maria and Dr. Jacob. Thank you very much. But my question is to Dr. Jacob, how the microorganisms we can use to improve the soil salinity, and what are the name of microorganisms, if you please mention. Thank you.
So that's a great question. So the question is what kinds of microorganisms and how do they interact with the plants, and then what are some of the names of these microorganisms? So the first thing is, how do these microorganisms interact with the plants in order to help them survive? One is that plants normally have some defense to salts. They have some tolerance to salt. Most plants have that. And so what these microorganisms are able to do is they're able to really work with the plants to really enhance the plant's natural, I guess, tolerance to salt. So where it would normally be tolerant to a certain amount of salt, the plants are able, or the microbes are able to get in, interact with the plant, and increase the plant's own ability to respond to salt. So that's one of the ways that the microbes are able to benefit. Another way is that a lot of times they're able to basically kind of do a kind of a protective barrier around the roots, and then they're able to increase or decrease the salt concentration within that barrier right around the roots, so that the plant doesn't see quite as much salt as there actually is in the environment. So there are a lot of different organisms that do this. There are a lot of bacteria, and there are also some fungi that are able to do this. I don't know if you kind of wanted to get down to some of the species level, but there are a lot of bacillus strains that can help to provide this benefit to plants. There are some there are some organisms, like there are halophytes that are plants, there are also some halophiles that are microbes that benefit as well.
Thank you very much, Dr. Jacob. Thank you very much for your detailed answer. But if you specifically mention what is the latest research which could tell us about the microorganisms which are used up till the now and for the improvement of the structure of the soil against salinity and sodicity.
Yes, that's a great question, and as far as organisms that are used to improve the structure of the soil, the salty soils, saline soils, the best remedy for this, as Maria has already explained, is not necessarily a biological solution. The best remedy for saline salts is through more sustainable practices. So it's management practices. It's the drip irrigation that she mentioned. It's maybe planting more salt tolerant crops. So the biology, the microorganisms are able to help us to grow plants in a higher saline soil, but they don't necessarily fix the problem. And so in order to fix the problem, we need to go back mostly to some of the more physical. So in some cases, you're needing to put on some compatible salt, some different kinds of salts that are going to basically flush the sodium out of the system, and then you'd have to put on a lot of water that's going to push that salt through, and it takes quite a bit to get this. The best way to solve the problem is through those sustainable practices of the fertilizers that don't have high salt concentrations, the making sure that your irrigation water and irrigation practices are sustainable as well.
Thank you very much. Thank you very much, Dr. Jacob.
Thank you so much. I see another hands up. Hamayat Khan, if you would like to unmute yourself and ask your question, please go ahead.
Yes, I'm Hemayat. I would like to ask JP, can we apply sulfuric acid in saline sodic soil for reclamation of sodium? Because it may be dangerous for microorganisms as well. Thank you.
So yes, the sulfuric acid is going to impact the saline soil, the microbes in the saline soil. The issue with it depends on whether you're talking about a sodic soil or a saline soil, and Maria might be able to better answer this after I've taken my best shot at it. So by adding sulfuric acid, you're going to be changing the pH. Now, if it's a sodic soil, that might not be as detrimental because you've already got a alkaline pH in sodic soils. But for a saline soil, it could cause additional problems if you are adding sulfuric acid that could potentially change the pH, could change the organic matter that is in the soil, and then also, you know, you're as you mentioned, you're impacting the soil biodiversity. Generally, what is a better approach is adding something like a gypsum salt, a calcium sulfate, or something like that, that then is able to basically help with the pH, buffering that pH, but as well, it's able to replace those sodium ions with less detrimental ions. Maria, do you have anything to add to that?
Yeah, I would compliment that indeed adding acids to soil is quite killing them in sense of biology or biological conditions, and so soil biodiversity will decrease for sure. So other alternatives should be considered if you want to maintain soil health. So which are, as Jacob mentioned, should be calcium-containing amendments. Either organic matter will also help, because as soon as we have organic matter which contains acids, but they are organic acids, which are milder, so it will be a good solution. And also any bioremediation methods when you grow crops, when you grow plants for remediating the soil could be a good solution. As soon as the plants create nice environment for soil health in many aspects, considering structure, porosity, organic matter content, and all the rest. Thank you.
Thank you. Thank you.
Thank you so much. I don't see any more hands, but I see one last question in the chat from Elias. They're asking, what parameters are best used to describe crop yield reduction in saline soils, not using usual parameters such as pH? Over to you.
Yeah, as I mentioned, so the best parameter to measure is salinity. So you measure it with conductimeter. But if you want, if you want to understand what is the crop yield reduction, so the measure can be that you make the crop cuts from the small plots, one per 1 meter, or half a meter, and then you compare. So you made this cut. You can measure the wet first, the wet productivity, the wet mass, but better to dry it in the oven with 105 degrees, and then you measure and you compare the yield from these two plots, and then you can see what is the crop reduction in these two plots comparing to the better condition and the worse condition. Maybe Jacob can complement.
No, I agree that yeah, just measuring that reduction in yield is probably kind of the approach that I would take.
Thank you so much. Does anyone else have any questions? Any last questions? And also, as Janice says in the chat, for more information about GSP, please check out the links in the chat, as well as email soildoctor@fao.org. All right, so if there are no more questions left, we can go ahead and close the session. I would like to extend my sincere thank you to our colleagues from the Global Soil Partnership, Maria especially, as well as Jacob, as well as to each of you for your active participation and contributions today. Today, we delved into the second part of our discussion on soils under better production, which is a key pillar within FAO's strategic framework for sustainable agri-food systems. As we reflect on the insights we've gained today, I encourage you all to continue your learning journey by engaging with the Global Soils Partnership, as well as the Youth Skills Hub, which is our World Food Forum's flagship initiative within our education track. This hub offers a wealth of resources, from interactive expert-led masterclasses, such as the one you all joined today, all designed to empower you with the skills, knowledge, and confidence to drive meaningful change in agri-food systems. Thank you once again for your dedication and participation. I hope today's session on soil salinity provided you with valuable insights that you can apply not only in your work, but also in your daily life. Together, let's continue advancing towards agri-food systems that are more efficient, inclusive, resilient, and sustainable. Let's strive for better production, better nutrition, better environment, and better life. I hope to see all of you again in our next masterclass. Thank you again, and have a good rest of your day.
Thank you to all. Goodbye.
Thank you. And also thank you to Janet.
Yes.
Of GSP. So thank you.
Thank you, Jacob. All right.
Thank you and goodbye.